Dear friends, today in this lecture I will discuss some important questions of Coulomb's force. So after this video, it will helpful to you to solve the important questions. Some questions are from previous year questions and also some are very important from your book. Today I will discuss all the questions of Coulomb's force. Let's start. So these are the 10 questions I will discuss today in this video. Question number 1. Comparison of a Coulomb's force and gravitational force. Question will come like this. You can note the question also in your paper. Question will come like this. Compare Coulomb's force and gravitational force between electron and proton separated by a fixed distance. This is the question. It may also come between electron and electron. It may also come between electron and proton. Doesn't matter. But I am doing now the question. Comparison of electrostatic force and gravitational force between electron and proton separated by fixed distance. Let us do question number 1. So you write fast electric force expression. Coulomb's force. Formula is K Q1 Q2 Q1 Q2, both charge EE, so I have taken the magnitude of charges divided by R square. You can put the value here, but don't put there. Now write the expression of gravitational force. G M1 M2, so ME MP divided by R square. Here also you can put the value and you can do the calculation, but that is extra labor, not required to do now. Now you, as comparison, let us find the ratio. This is the comparison, electrostatic force to gravitational force. Let us find the ratio. So ratio is coming, you see K E square divided by G ME MP. R square will be cut, so this is the expression. Now you put the value, so your calculation will be less, but here don't put the value, calculation will be more. Now you can put the value here, 9 into 10 to the power 9, K you know, so this is 1.6 into 10 to the power minus 19, this is square. Then value of G you know, 6.67 10 to the power minus 11. Then ME, all these values you will get in board exam on the front page of your question paper. This is the ME, mass of electron, you know, 9.1 10 to the power minus 31 kg into mass of a proton 1.67 into 10 to the power minus 27 kg. So calculation is yours. Calculation you will do. I am not doing the calculation here. If you will be unable to do calculation of these values, at least you can do the calculation of the powers. No problem, you can do at least the calculation of powers. If you do the calculation of powers, you know in class 11th that electrostatic force and gravitational force is equal to 1. Electrostatic force is stronger than gravitational force, and it is, answer will come around 10 to the power 36 or 37 like this. Electrostatic force is stronger, so answer will come around 10 to the power 36 or 37 like this with some value. Some value into like this, the answer will come. If it is 1 or minus 1 plus or minus, then it doesn't matter. Okay. So this is the comparison between electrostatic force and gravitational force. It's an important question, sometimes comes in exam. And from this it's also practically you are now clear what you have read in class 11, that electrostatic force is stronger than gravitational force. How much times stronger? 10 to the power 36 times stronger. You have read in class 11th in comparison. So this is about question number 1. Another question also you can see in different exams from here. In MCQ you may see what is the dimensional formula with this? K E square by G ME MP. Sometimes in some MCQ question you will see what is the dimensional formula with this. So what is the dimensional formula with this? Actually now from this if we want to do much more calculation, then we will put their dimension individually. But it's very difficult. Don't do that. But you remember that K E square by G M E and P is the ratio of electrostatic force to gravitational force. So as it is the ratio, what is the dimensional formula? M0, L0, T0. It's very simple. As it is the ratio, dimensional formula is M0, L0, T0. It's over. So this is the one from which we got one numerical type question and one MCQ question also you can find, or this is also one mark question. Now you go to question number 2. Question number 2 you now see. Question number 2 what happened? Distance double question first will do. This is very easy. Small children also can do, your juniors. Distance double means this is question will be like this. Two charges are there separated by a fixed distance. If the distance between them will be double, what happens to the electrostatic force? Now you can also tell this answer. K Q1 Q2 by R square. If distance will be double, then what will happen here? Q1 Q2 by 2R. Double means distance will be now 2R. 2R square. So it is nothing but F by 4. So now force will be 1 by 4 times if distance will be double. Then another question we can do from medium change. From the medium change type here, say the very simple one, medium change type question I am doing, based on this Coulomb's force. Medium change question will come like this. Between two charges are there, separated by a fixed distance. If a plastic rod is inserted between them, a plastic medium is inserted between them, what happens to the electrostatic force? What do you think? What happens to electrostatic force? It will increase or decrease? So this is the, if I write fast in air the expression is 1 by 4 pi epsilon naught Q1 Q2 by R square. But in medium the expression is 1 by 4 pi epsilon naught K Q1 Q2 by R square. What happens here? One term K is coming. So this is in air. So F medium is always F air by K. Dielectric constant K is there. I have told you K is 1 for vacuum and for other mediums K is always greater than 1. K is always greater than 1. Okay. So as K is always greater than 1, so if we introduce plastic medium, as K is greater than 1 here, what happens to now the force? It's more than 1. So F medium will be less than F air. If any insulating medium you insert between two charges, any insulating medium, the force between two charges will be less than that of air. Always remember, force is maximum in air, then decreases in other mediums, other insulating mediums. But what happens if the question will come, a brass rod is inserted, a metal rod is inserted, or a metal medium is kept, what happens there? So if metal medium is kept, what happens to this value of K? For metal K is equal to infinite. This is the data. For metal K is, but why for metal K is equal to infinite? You will read that in the next chapter. Why for metal K is infinite? But now you remember, for metal K is infinite. If K will be infinite here, this K is infinite. What happens to now the force? Now the force is 0. So if metal medium is inserted, remember always force is 0. Now I am combining both medium change and distance change. Another question I am telling you, combining them. The question will be like this. Two charges separated by some distance exert force F on each other. Exert force F on each other in air. If a medium of a dielectric constant K is inserted, to get the same force, what will be the new distance? I am repeating the question again. If two charges are separated by some distance in air, exert force, electrostatic force F on each other. If a medium of dielectric constant K is inserted between them to get the same force, what will be the new distance of separation? This is a good question. So let us do that question. In air, what happens to force? In air, this is 1 by 4 pi epsilon naught K Q1 Q2 by R square. So in medium, I introduce the dielectric medium. In medium, 1 by 4 pi epsilon naught K Q1 Q2 by, this giving R dash square. Because now distance will change to get the same force. Same force means both air and for air and medium, both forces will be same. So now you see, now you write it here, 1 by 4 pi epsilon naught Q1 Q2 by R square, and here 1 by 4 pi epsilon naught Q1 Q2 by R dash square. So this cut, Q1 Q2 cut. So what you get here? So R square is equal to R dash square into K. So R dash is equal to R by root K. So this is the answer. Now you got it. So this is the question number 2 is now over. Now come to the question number 3. Concept number 3 here. Conduction and Coulomb's force. How these questions will come in exam? Conduction and Coulomb's force. The combo questions of conduction and Coulomb's force. I have told you, when two bodies comes in contact, they become like charge. And also I have told you another thing. If they are identical, shape and size, same material, then charges equally divide between them. But how the question will come in exam? This is the concept of conduction. How the question will come? Question will come like this. Two bodies, one is positive, one is negative. What is the nature of force between them? Now again the question will extend like this. If they come in contact with each other and they get separated by same distance, now what will the nature of force? If, now coming to answer, both are positive, negative, what is the nature of force? Attraction, attractive force. But now if they come in contact with each other and then they get separated, then what happens? Now both will be like charge. If both will be like charge, now they start repelling each other. So after contact, they get like charge, they repel each other. But the problem is, if both are identical and had same charge, now they get neutralized. The charge is neutralized and force will be 0. Force will be what? 0. Now you understand this one. Again I am telling you, if two charges are, suppose two bodies has opposite charge of different magnitude. If opposite charge of different magnitude, then now the force is attractive, but after contact and separation, now the force will be repulsive because they will get like charges. If same magnitude, identical body, same material, they get neutralized and force will be 0. Question can come like this from conduction. Also can numerical based type question, can concept this type of question. Two bodies has a charge Q and minus 4Q. The force between them is F. When they come in contact and then get separated to same distance, what is the new force? Question may come like this. So Q, I told you, one body charge is Q, another body charge is minus 4Q. The force F is K, Q, 4Q. I took only the magnitude of the charge by R square. This is the force between them. But when they come in contact, what will the charge now? Q1 dash. Both bodies are identical and same in size. Otherwise, identical, same in size, same material. Otherwise, you can't able to solve this question. So the charges equally divided. Q minus 4Q by 2. So this comes minus 3Q by 2. So this is now the charge of each body, minus 3Q by 2. So what is the new force now? So K 3q by 2 by r square. So what is the force now you see? So here we can also do this calculation, 4k q square by r square, and here the force will be now k, this is 9k q square by 4 r square f dash. Then you can do this comparison dividing f by f dash, you can get the answer. How much will be the f dash? Relation of f dash with f you can able to find out. Just dividing them, you can get the answer. You get this type of question from numerical based question from conduction and Coulomb's force. Now we come to the concept number 4, superposition principle. What type of question we face from superposition principle? Let us see. Superposition principle means many charges will be there. Question will be asked to find the force on one charge. Let us do one simple question. 3 charges are there on the vertices of an equilateral triangle of side D. 3 charges, equal charge, plus q charges are there on the vertices of an equilateral triangle. Find the force on expressed by each charge. Question will be like this. This is the question. Then how you find the force on each charge? Let us consider any one charge because it is a symmetrical figure. Doesn't matter which charge you are taking. You take now this q. This q apply force on this q in which direction? It's attractive or repulsive. Now it is repulsive. On this q I am finding this force. It is repulsive. On this q will repel here in this direction. F1 force vector. This plus this q now force on this one. So it will apply here on this one. So from here we will see the line. This is F2 force. F1 F2 force. This is one equilateral triangle. So this angle will be 60 because this angle is also 60. Let us write the magnitude of forces. F1 is K Q1 Q2 Q by r square. All sides are same. D or d square. So F2 is K Q square by d square. So both forces are same. Now we have to do the vector addition. How to do the vector addition? F vector is equal to F1 vector plus F2 vector. So if you find the magnitude of F vector, simply you have to use triangular law. You have remembered in class 11. So F1 F2 cos 60 root over. But F1 F2 both are same. As both are same, you will get here root 3 F1. In place of F2 you put F1, you will get root 3 F1. So root 3 K Q square by D square. So this is the answer. And what is the direction of the force? In exam also the question will ask from direction. If direction will ask, you can show the direction in the figure. If you show in the figure also you will get the mark, no problem. 60, underlying 60, both forces are same. Obviously the resultant will go like this, making angle 30 degree. Making angle 30 degree with H. So you can write the direction also. Direction is 30 degree with F1 or F2 you can write. 30 degree with F1 or F2 you can write. You have to also show the figure. You can show in the figure. This is the force. So this is the simplest question. Simple question of superposition principle. This is called triangle question. You can remember that formula also. If both all are upside magnitude, force is root 3 F1. You can remember this value to write the answers in MCQ. No problem. So now we'll come to the. You can do this question also by component method, but I think here this triangular law method is more easy to you. If component method is easy, then you can also do the component method. We'll come to now the square problem. Square problem is like this. 4 charges will be there on the vertices of a square. You see 4 charges will be there. Q. Question will be asked to find the force on any charge. If the question will ask to find the force on any charge, all charges are same, we can find on any charge, no problem. So let's find on this charge. Plus Q, all at once. Positive. It can be also minus. Like if it will be minus, if these two will be minus, according to the question will change. You have to do. Physics question can change. From one question we can generate 10 questions like this. Okay, but I am doing here one only. If your concept is clear, understanding is clear, you can able to do the other questions. So if plus Q, so first now see what happens to this plus Q, when in which direction it will apply the force? Repel. F1. This force it will repel. F2. This force also it will repel. This is F3. Now you see. Now write the magnitude of the forces. F1. I am writing only the magnitudes. K, Q1, Q2, Q square by D square. Distance you take D. All distances are same D, and this will be root 2D, as this is the diagonal. So F2 also K, Q square by D square. But F3 K, Q square by root 2D whole square, K, Q square by 2D square. Now we will add these three forces by polygon law. Polygon means we have to add the easier ones, F1, F2 first, then with F3 you add. First you add F1, F2, it will be better. If you add F1, F2, the angle between them is how much degree? 90 degree. And the resultant will just go in between them, means along F3, resultant of F1, F2, because both forces are same in magnitude. Okay, so let us first add F1 vector and F2 vector. You know, if both vectors are perpendicular to each other, resultant value will be F1 square plus F2 square root over. Simply write root 2 F1. You put in place root 2 F1, root 2 F1. Now the resultant of this direction of this force will be along F3. Now what is the net force here? Net force will be simply F3 plus root 2 F1. Why? But these two forces are in the same direction. Not required to use any triangular law. Simple addition you can do. Now you put their expressions. K, Q square by 2D square. Then root 2 F1 is K, Q square by D square. Now you can add them and you can simplify. Under direction, you can write the direction. You can show the direction here. The resultant force direction is here, or you can write it also. That is making angle 45 degree with F1, or it is along the diagonal this. You can name this diagonal, and the resultant, the direction you write here. Direction is along the diagonal. You can write it. You can name the diagonal also. You can give the name here A, B, C, D. A, B, C, D. It is along the diagonal from D to B. From D to B in that direction it acts. So this is the square question. Square question this is. You can simplify, you can get the answer here. Root 2 plus 1 by 2 whole into K Q square by D square. Okay. Then from that you can find also, if I'll go to another question which is in your NCERT book example, that triangle question. You can see here triangle question you see. Suppose in a triangle, three charges are there, Q, Q, Q. In middle there is a capital Q charge at the center of an equilateral triangle. Question will come, find the force on capital Q. What we'll do here, we'll find the forces. Here you see this, all are positive, this is also positive, this is also positive. So it will repel in this direction, F1. It will apply in this direction, F2. It will apply in this direction, F3. Then we have to add these three forces to find the net force on Q. What to do here? We can write the forces. If you see, you take this distance as R. It's better you make the side negative, but doesn't matter. You take the distance from the vertex to the center as R. You can write the expressions. K, Q by R square. It is also same as F2. It is also same as F3. All the three vectors will be of same magnitude. If you see, three are same magnitude, and if you see the angle between F1, F2, F3, between F1, F2, between F2, F3, and F1, F3, this angle, this will be 120 degree. Angle between them also will be same. Means I can write here F1 by sine 120, F2 by sine 120, F3 by sine 120. All three are same here. as F1, F2, F3 are same. Can you able to now recognize this formula? 11th class vector chapter, this is the Lami's theorem. As it satisfies Lami's theorem, so all the three vectors are in equilibrium. That means F1 plus F2 plus F3 vector is equal to 0. It will write here, it is satisfy Lami's theorem. So plus 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 is equal to 0. Means net force on capital Q will be 0. So this is about triangle. If I take also a square, but all vertices contain equal charge and there is a small q, what is the net force on this small? What is the net force on this capital Q? If capital Q is present at the center, also net force will be 0. No problem. Net force also will be 0. You can see here the forces will cancel each other. This force and this force cancel each other. This force and this force they cancel. Here it is clearly they cancel each other here. So they cancel each other and net force will be 0 if it is a square. But if I extend this question to a pentagon, suppose I take one, if I extend it to a hexagon, then also net force will be 0. If I take a hexagon, also net force will be 0. But if I extend to suppose one 13-sided polygon, one regular 13-sided polygon, each corner contains small q charge. What is the net force on capital Q placed at the center? What will the answer now? It's coming to your mind. 13-sided polygon. If you are thinking the answer will not be 0, then it is wrong. The answer will be 0. It is coming to your mind. Answer will not be 0. It is coming to your mind because you are thinking it's a 13 number. So it's an odd number. 12 charges force will cancel. 1 charge force will remain. So it will not be 0. No, don't think like that. Maybe even, maybe odd. Maybe 99 side, maybe 113 side, maybe 1013 side. But if it is regular polygon, one charge is present at the center, all vertices contain same charge, then net force will be 0. Why? Now you see about triangle. Also in triangle 3 is an odd number. How the force is 0? So only thing is if it is even number, forces are coming just opposite to each other. So they cancel. You visualize the cancellation. But if when it becomes odd number, you cannot visualize the cancellation. But net force will be 0. How? They arrange in such a way that they will provide their components and the components cancel each other. Forces will not come just opposite to each other if the number is odd. If the number is odd, forces will not come opposite to each other. If the number is even, if 4-sided, 6-sided, 8-sided, then forces come opposite to each other. So you are understanding. But if it is odd, also the force will be 0 because their components cancel each other. So don't think like that. But if the question will come like this, in a 13-sided polygon, 12 vertex contain charge small q. Capital Q is present at the center. From one vertex no charge is there. At one vertex no charge is missing. Now what is the force on capital Q? What answer is coming to your mind? If it is coming 0, no, that is wrong. Because it is a 13-sided polygon, but 12 vertex contain charge. One vertex is not there. How will you solve this question? If you find for 12 charges individually and add them vectorically, it is very difficult. But don't do like that. We will prove that one. That question I am solving. You see. Again I am repeating the question. In a 13-sided regular polygon, each 12 corners contain charge small q. At one corner no charge is there. Capital Q is present at the center and the force on capital Q. So you just imagine the corner where charge is not there. You imagine suppose one charge is there, like the other charges present on the vertex. Suppose one charge is there, like the other charges of same magnitude. If now you think 13 charges are there, if 13 charges are there, then what is the net force? 0. You know, just before I told you. If 13 charges are there, then the net force is 0. Now you divide them into 12 and the missing one. This is the missing one. This is I am writing. This is the missing one. Missing charge. So H2. So what about this 12? Apply the force minus the missing one. Finding the force of 12 charges is equal to finding the force of only missing charge. Which one is better? Finding the force for 12 charges is better, or finding the force for only the missing charge is better? Better find for the missing charge. If from missing charge we find minus KQ by R square. R is the distance from vertex to the center. But the direction will be just opposite. Minus, for that I will give the minus. So minus KQ by R square. Accordingly we will decide the direction of that. So these are the questions related to superposition principle. Now we'll come to the question. Suppose series question. For the series question will come like this. Many charges, each of magnitude small q, are present at x is equal to 0, x is equal to 1, 2, 4, 8, and so on. And the force on the charge present at the center, present at the origin. How will find? This is called a series question. Okay, charges are present like this up to infinite. How will find the force on this? Simply, now you see this charge will apply the force in this direction. All are positive charges. All are positive charges. Also, this charge will apply in this direction. This charge also will apply in this direction. All repel this charge. Now let us find out this. As all forces are in the same direction, so simple addition. No vector addition is required. So F is equal to K due to this charge first. Q square by 1 square due to this charge. K Q square by the gap is 2 square. Then due to this charge, K Q square by 4 square. Then due to this charge, K Q square by 8 square. Now you see. K Q square you take common. 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 plus dot 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 the dot 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 of infinite extent. So this comes under a series. This is, I think, now you see which series, AP or GP? This is a GP. And when infinite is GP, what is the formula? A by 1 minus R. The summation of infinite is formula A by 1 minus R. A means first term, 1 minus R means common ratio. You see the common ratio 1 by 4, 1 by 4, 1 by 4, 1 by 4. Now you solve it. So this is called series question. Now you come to the graph question. We will solve this question. Now you come to the graph question. In graph question, what happens? Graph F is equal to K Q1 Q2 by R square. Graph between F and R. F and R is inverse proportional graph. Graph between F and R square. This is also inverse proportional graph. Graph between F and 1 by R square. 1 by R square means F directly proportional to 1 by R square, but F inverse proportional to R square. Okay. If a direct proportional graph will be like this, starting from origin. So this is the graph question. But in previous year exams, question come like this. I am extending this question again. Question come like this in previous year exam. Draw the F versus 1 by R square graph for 1 microcoulomb, 2 microcoulomb, 2 microcoulomb minus 3 microcoulomb. For these two pairs, draw F versus 1 by R square graph. This question came in the previous year. It's a very important question. How will draw the graph? You see, graph obviously will be a straight line starting from origin. But here force is positive, but here force is negative. This is attractive force will write the sign negative. So I am drawing the graph like this, you see. So positive, in positive quadrant this force will be 2 microcoulomb, and in the negative quadrant this force will be, you see, this is the force and here is the force. If we draw in this quadrant, it's okay, no problem, but some teachers also got your mark. Because why you are not showing the negative sign? Okay, so better you draw like this. This is 100% you will get full mark in this. No teacher cannot got any mark here. But the question is here, F is equal to K Q1 Q2 by R square. You can mark, I have done this angle small, but I have done this angle more. Why I have done it like this? Here theta 2 is greater than theta 1. Because when F and 1 by R square will draw the graph, this is 1 by R square, will draw the graph. This is the slope of the graph. Slope of the graph. Slope means product of Q1, Q2. K is constant, product of Q1, Q2. Here Q1, Q2 product, here Q1, Q2 product. So which product is more? Magnitude. Here it is 6 coming, here it is coming 3. This product is more. If this product is more, slope is more. If slope is more, then tan theta is more. Tan theta is more means theta is more. For which this theta is more. We have to show it here. Theta 2 greater than theta 1. In exam also it may come. We have to explain why theta 2 greater than theta 1. As slope is more, so tan theta is more, theta 2 greater than theta 1. So now I will go to the next question, equilibrium question. Equilibrium question, what type of question comes from equilibrium? One question is very important here. Q charge is here, or here capital Q, here capital Q charge is here, and small q will be here. Distance of separation same. Small q charge is present at the center of two equal capital Q charge. What should be the relation between capital and small q if the system is in equilibrium? This is the question. What is the answer of this question here? You see, so system in equilibrium means, you remember this concept, force on each charge is 0. Force on capital Q 0, force on small q 0, force on this capital Q 0, force on each charge is 0. Then the system is called in equilibrium. So now I will find the force. On which charge you will find the force? You see, okay, I will find the, you are telling to find the force on small q. Small q. Okay, I will find the force in small q. K, Q, this q apply the force, d square. This q apply the force, K, Q by d square. Net force is 0 and make it 0. You can ask how you add the forces simply. Actually, I don't know the sign of the charges. I don't know the direction of force. You just simply add the force, automatically the answer will come with a sign. In this question, generally you would do like that. Automatically the answer will come with a sign. You add them. Because as you don't know the sign of the charges, you don't know the direction. We cannot take any direction from them. So if I add them to KQ by d square is equal to 0. So d square will go to right side 0. All go to right side, everything is 0. Can you get an answer from this? No. So to remember one question here is very important. Don't find the force on the center of the charge, small q. If you find on small q, you will not get an answer in the exam hall. Then your mind will be disturbed. So don't do like this. I did only to show you. Don't do like this. You find the force on the side charge, small capital Q. Let us find the force on this charge, K, Q by d square plus K Q square by this charge will apply the force on this. This is a d plus d, this is 2d square equal to 0. Then you solve it. You will find the relation between Q and Q, small q, obviously you will find capital Q by 4. This is the answer. And you are getting the answer also with sign, minus sign, means capital Q, small q will be of opposite nature. Otherwise equilibrium is not possible. This is about equilibrium question. Now Q divide question. The question is like this. Charge Q has to be divided among two bodies such that force between them will be maximum. Question is like this. Separated by fixed distance. Okay. So if you divide between two bodies, suppose charge Q, one body will take charge x, other body will take charge Q minus x. So force between them will be maximum. Let us get the expression of force. K x Q minus x divided by r square. This is the force. Force becomes maximum. You have done this type of question in gravitation chapter. Force between them maximum. You know this concept from 12th class derivative integration, that when a quantity becomes maximum, its differentiation is 0. So as maximum df by dx, differentiate with respect to x. Why x? Because x is our variable, is equal to 0. You just differentiate it. If you differentiate it automatically, you will get your answer x is equal to q by 2. This the answer you will get. Differentiation is up to you. You can do the differentiation from this. Very easy differentiation. So this is the q divided. Coming to the next question, pitfall problem. Now see, pitfall problem. Pitfall actually it has 3 questions, but I will discuss one question from pitfall. Concept number 9. 2 like charges are hung from a point by the help of a string of length L. Then 2 like charges. If 2 like charges are hung, this is called two pitfalls. 2 pitfalls equally charged there. Equally charged. The charges are equal nature, equal magnitude. May not be equal magnitude, doesn't matter. But if equal magnitude, I am always generally it gives equal magnitude. Charges equal magnitude, equal nature. If equal nature, same nature, what happens like charges? They repel each other. They remain like this. This one pitfall question is one. And from this question, many questions it can generate. Let us solve the concept here. If the system is in equilibrium, in whose direction the different forces act, take one pitfall. I am taking this ball only. I can also take no problem, but I am taking this one. Mg act here. This charge repel this charge. Coulomb's force act here. Tension act also in this direction. You see this angle is theta. Take this angle theta. If this is theta, tension can result into 2 components. 2 components. Here is also theta. It is T cos theta. It is T sin theta. So T sin theta, as it is in equilibrium, T sin theta equal to F and T cos theta is equal to mg. So divide these 2 equations, you will get tan theta is equal to F by mg. So this is the main formula. From this formula, the question can be of different type. What is the mass? May ask what is the angle. Many questions you will ask like this. So tan theta is equal to F by, then F, you can put here F. F is K Q square divided by R square. But what is R? R is the this distance. This plus this. But if length of the string is given, this angle is theta, then this is L sin theta. If this is L sin theta, totally is 2L sin theta. So 2L sin theta square. Then mg is there. Then from this expression, what is asked in the question, accordingly you can do. If you ask what is the mass, you can take the mass to one side, others to one side. If you ask what is the angle, then you can also find the angle. Many more things. If you ask the charge, you can find the charge. What is the magnitude of the charge? But I just told you the concept to solve the pitfall question. This is of equal charge. If I am doing another question of pitfall, if both are unlike charges, then they generally hung like this. From one is this point, from one is this point. If they are unlike, they attract each other. They attract each other. If they are unlike charges, they will remain like this. Then accordingly, I told you the concept here. They attract each other. Force will be in this direction, tension will be in this direction, mg will be in this direction. Then you will take the angle theta. Then you can proceed this question just like the previous one. You understand the concept of previous question, you can solve this question now. If both are unlike charges, they attract each other. Accordingly, we can do. Then come to the last question, minimum possible force. It is a very simple one. What is the minimum possible force between 2 charges separated by some distance? What is the separated by 1 meter distance? What is the minimum possible force? If force will be minimum, then magnitude of charge will be minimum. Only force will be minimum if magnitude of charge will be minimum. So 1 by 4 pi epsilon naught. What is the minimum magnitude of charge? Charge of 1 electron. So obviously E into E divided by, if I mean 1 meter, then 1 square. Then you can put the values and you can get the answer. So today I discussed the concepts. Many questions from these 10 concepts of which type of questions generally comes from Coulomb's law. I hope these questions will help you for your exams, school exams, as well as for your board exams in final. Thank you.